5.1 is all about logarithms and their properties. So, if x is a positive number, log x is the exponent of 10 that gives x. In other words, if y equals log x, then 10 to the y is going to equal x. So basically what this means is logarithm is the inverse of an exponential function. So if we have log 4 equals 0.602, we know that 10 is missing here. So this is going to basically be 10 to the 0. Sorry, I'm slow, but 0.2. This is going to equal 4. Okay, moving on. Logarithmic and exponential functions are inverses. This is what I explained before. So if 10 to the y is x, then y is going to be log x. This is basically an exponential function, so logarithmic is going to be the inverse of the exponential function. For any n, log 10 to the n is going to equal n, obviously, because, well, 10 to the n is, well, n. And for any positive n that's bigger than 0, 10 to the log n is going to equal n. So, for example, if we have log 10 is 100, 100 is basically 10 squared, so we know this is going to be 2. So 10 squared equals 100, so 2. Okay, again moving on, properties of the common logarithm. By definition, y to the log x means that, as we said before, 10 to the y is going to equal x. In particular, these two are important ones that you should keep in mind because they will come in handy. Log 1 is always going to equal 0 because no matter which number you do, these are all always going to equal the same number, which is 0. That's just like a promised thing that we have. Oh, my bad. 1, not 0, 1. And as for log 10 equals 1, this is basically just for like any other numbers. Since when we don't have this, we know this is 10 under here. So if 10 to the 1, we know that that's going to be 10. So basically this is 1. But if we say that this was 2, it was log 2 to the 2. Log 2, and it was like square here, and you would say this was 2. Then what would go here? That would, 1. This would be 2, because 2 to the 1 is going to equal 2. So these are 2 to keep in mind. Other examples would be these. Just take a look at them and that'd be fine. And then also, again, moving on, the functions 10x and log x are inverses, so they undo each other. Well, that's something we all know. Since they're inverses, they're obviously going to undo each other. So if we look at examples, if log 10x to x for all x, then those are all going to be right. And for a and b, both positive and any value of t, these are the properties of log, which is very important. If you have log ab, this is going to be the same as log a plus b. Important that inside here, log a plus b is not going to equal log a plus log b. Also the same thing, log a over b is going to be log a minus log b, not log inside the parentheses a minus b. That is not going to equal log a minus log b. That's totally different. And this one is also very important. Log b to the t is going to be t times log b, which basically we just kind of brought the t out to the front. Okay, again moving on, the natural logarithm. for any x that is bigger than 0, natural log x is the power of e that gives x. Is going to be the power of e that gives x. Or in the symbols, natural log x is y, then that's going to mean that e to the y is going to equal x. Again, these are going to be inverses of each other, so if you keep that in mind, that'll be a lot easier. And also, y is called the natural logarithm of x. So, properties of the natural logarithm are kind of similar as just the normal logarithm. By definition of y equals natural log x, that's going to mean that x is going to equal e to the y. In particular, natural log 1 is going to equal 0, and natural log e is going to equal 1. These are both the same as we did before up here in properties of the common log, except we have the natural log here. And again, there's an e that we don't see here. So basically, e to the 1 is going to equal e, so always going to be the same. So the functions of e to the x and natural log x are inverses, so they undo each other. Again, the same as the normal log, and this is just a repeatance of the properties that we did before. So if we move on now, misconceptions and calculator errors involving logs. This is what I kind of explained before when I said to make sure that log inside the parentheses a plus b is not the same as log a plus log b, which explains right here. So these are things to keep in mind. Log ab is not the same as log a, b. But you can memorize this if you want, but if you just know these three up here, there's really no reason to do that. So just make sure you keep these three in mind. Okay. So this is kind of just a reminder again, because these properties are going to come in handy so much. So you really want to memorize these. And I'll just go over them one more time and we'll end this session. So again, if 10 to the y is x, then y is going to equal log x, again because they are inverses of each other. And since we know this, because we've done this a lot during functions, a times b is going to equal 10 to the m times 10 to the n. This is the same as 10 to the m plus n. So we use this exactly here. Log inside the parentheses a times b is going to equal log a plus log b. Again, here, a over b, if we say that this is 10m over 10n, is the same thing as 10 to the m minus n. Again, we use this to here, exactly. Log inside the parentheses a over b is a log a minus log b. And last but not least, this is very important. If b to the t is 10k, and then you power that whole thing by t, it's going to be the same thing as 10 times kt, because you would multiply these. So we use that again here. Log b to t is t times log b. So these three I would really recommend you keep in mind, and that is it for logarithms and the properties.